NASA is developing coatings that visually appear as absolute shadow. These materials absorb almost all incoming light. One of the most effective options is a coating based on carbon nanotubes. Its structure resembles a forest of microscopic tubes into which light falls and does not reflect back. Such a material was created to minimize glare inside optical devices, such as telescopes, cameras, and sensors. The use of these coatings allows NASA to obtain more accurate images of stars, galaxies, and other faint objects. They reduce the amount of scattered light and make space optics much more sensitive. Super black materials are used in telescope experiments, including those aboard satellites. In addition, NASA is testing them in stealth prototypes to make space modules less detectable in certain observation spectra. However, no public source confirms the existence of a completely invisible device. So far, the technology only allows for partial reduction of reflection and only under limited conditions. At the same time, the materials themselves must be highly resistant to vacuum, radiation, and temperature fluctuations. This example demonstrates how far NASA's materials development has come, from optics to camouflage. And this is only the beginning. After all, if you can control light, can you control information itself? NASA has unveiled its first ever quantum memory module, developed at the Glenn Center. This is not a theory, we are talking about a real experimental device. It allows information to be recorded and stored using the quantum properties of matter. This is an important step toward creating secure communications and new computing systems, especially in space conditions. In classical systems, data is stored in bits, which take the value of either 0 or 1. Quantum memory uses qubits as information carriers, which are capable of existing in multiple states simultaneously. In NASA's version, data is recorded in a cloud of laser-cooled atoms and then transmitted using photons. This method provides a high level of protection against interception or signal tampering. For now, the project remains at the laboratory stage. NASA emphasizes that the goal is to understand how quantum memory works under stable conditions before sending it into space. If the technology proves to be reliable, it could be used in satellite networks and communication systems for interplanetary missions. This opens up fundamentally new possibilities. After all, if memory can be made quantum, the next logical step is to move toward quantum computing. And NASA is already moving in that direction. And they have a laboratory where such algorithms are being developed right now. NASA's Morpheus project is a test platform created to develop vertical landing technology. Its unique feature is that the craft is able to independently analyze the landscape and choose a safe landing site, without human intervention in real time. This technology is extremely important for future missions to the Moon and Mars. There is no infrastructure there, and manual landing could be too risky. Morpheus uses laser rangefinders and an onboard computer to observe the surface during descent and adjust its trajectory on the fly. The craft underwent tests on Earth, including vertical takeoffs, trajectory flights, and soft landings. One of the successful tests took place at NASA's center in Houston. Although the project itself has ended, the technologies developed within it are now being integrated into real space missions. The idea is simple. Robotic systems must be able to land where it is impossible to mark out a landing site in advance. This is especially important when exploring uncharted areas of the Moon, where each new location may contain unique data. If Morpheus was only paving the way, now NASA is betting on larger systems that are not only capable of landing but also of performing tasks autonomously. Such developments are already being used in other missions, including Mars exploration. NASA is not only about space flights, but also a source of technologies that we use on Earth every day. These inventions are called spin-offs, when a development for space finds application in everyday life. And there are hundreds of such examples. For example, infrared thermometers, which allow temperature to be measured without contact, appeared thanks to technology originally created for astronauts. Memory foam materials, widely used in mattresses and footwear, were developed to absorb the impact during capsule landings. Water filters using activated carbon and fine membranes were originally used in water purification systems aboard space stations. Today, they purify water in homes and in the field all over the world. Satellite positioning systems, smoke detectors, medical sensors, and digital image processing, all of these have partially or fully grown out of space programs. NASA publishes an annual catalog of its spin-offs, documenting every technology that has transitioned to civilian use. These innovations are direct proof that space exploration benefits not only those in orbit, but also our everyday lives. But some NASA developments don't go into commercial use, instead ending up in classified projects where they are used for defense and intelligence purposes. NASA is considered a civilian agency, but it actively collaborates with U.S. military organizations. This cooperation is especially evident in dual-use projects, where technologies are developed simultaneously for science and defense. For example, NASA participates in joint programs with DARPA, the Defense Advanced Research Projects Agency. Together, they study new types of engines, autonomous systems, and materials capable of withstanding extreme conditions. These technologies can be used both in space and within the atmosphere. Another example is spy satellites and reconnaissance platforms. Although NASA does not officially engage in surveillance, in some cases, it provides technology and expertise for military satellites. Cameras, navigation systems, and control systems, all of these are developed jointly with the Department of Defense or at its request. There are also programs that are known only from budget documents, without any technical details. They may include experiments with camouflage, cybersecurity, or communication systems. NASA is required to follow federal security standards, and some of its divisions are certified to work with classified information. This does not mean that NASA is hiding the truth. Rather, part of its activities fall into areas where national security is the priority. This is an important but little-known aspect of its work. NASA conducts research not only in deep space, but also in Earth's atmosphere. One of the unusual projects is CARE, the Charged Aerosol Release Experiment. Its goal is to study how charged particles behave in the upper layers of the atmosphere, especially in the ionosphere. As part of the experiment, a rocket delivered a cloud of fine charged particles to an altitude of about 200 miles. These particles were then observed using radar and optical instruments. This made it possible to study the behavior of plasma, waves, and magnetic fields. Such research is important for communications, navigation, and understanding the influence of space on Earth. Some viewers might confuse this with conspiracy theories. Supposedly, NASA controls the weather. But in reality, this is scientific work aimed at studying natural phenomena. Everything is conducted openly with publications and permissions from international organizations. CER is not the only experiment of this kind. NASA also collaborates with other agencies on projects to study the magnetosphere, solar wind, and auroras. To do this, both rockets and satellites are launched, carrying sensors and field generators on board. These studies help protect Earth's technology from solar storms and improve the reliability of communications. NASA has long since moved beyond experiments. There are now real devices operating on Mars that use advanced technologies. One of them is the Perseverance rover. It is equipped with an autonomous navigation system capable of analyzing the terrain and avoiding obstacles without commands from Earth. Nearby, the Ingenuity drone is operating, the first aircraft in history to take flight on another planet. Its flights have proven that aerodynamics are possible even in the thin atmosphere of Mars. It flies according to a set program using lasers, cameras, and stabilization algorithms. Power is supplied by a nuclear battery that operates continuously for years. This allows the systems to function independently of solar activity or weather conditions. Data transmission takes place via satellites in Mars orbit, which relay the signal to Earth. But most importantly, all these devices are not just surviving, they are conducting experiments. They analyze soil, collect sounds, and test oxygen generation systems. This is not only a demonstration of technology, but also preparation for future manned missions. NASA has already proven that autonomous systems can operate on another planet. But the question remains, why do some of the technologies involved in such missions remain unknown to the general public for so long? NASA is no longer just launching rockets, it is developing the infrastructure for a new stage of space exploration. One of the key projects is the Artemis program. Its goal is to return humans to the moon and create a permanent lunar station that will serve as a staging point for missions to Mars. The technologies that NASA is preparing for these missions are astonishing. These include ultra-lightweight materials capable of withstanding intense radiation, new laser-based communication systems that transmit data faster and more securely. Autonomous modules are also being developed that will be able to operate without human intervention. Quantum computing, ion engines, self-servicing modules, all of this is coming together into a unified ecosystem of the future. Technologies are already being tested in laboratories for extracting oxygen from the Martian atmosphere, robotic assistants capable of building shelters on other planets, and new types of energy sources. Special attention is being paid to safety. NASA is investing in radiation protection systems, autonomous diagnostic systems, as well as new medical technologies to ensure the crew can survive on long-duration missions. Missions are no longer limited to Earth's orbit. NASA is looking further, to the Moon, Mars, and even beyond the solar system. And many of the technologies we've discussed are no longer just theory. They exist. It's just that not all of them have been revealed yet.